Hi students, this is the second part of the Simplifying Polynomials notes where we multiply monomials by other polynomials. So you're going to use the same printout if you printed those out. We're just doing the last half. Okay, so the last set of notes we were combining like terms by adding or subtracting them. And the terms that were like had to have the same variable or variables raised to the same exponent. When we're multiplying monomials, they do not have to have the same variables raised to the same exponent. They can, they don't have to. Okay, so we're going to look at what happens when they do have some variables that are like. So when you're multiplying monomials and they do have some variables that are like one or more, right? What you're going to do is you're going to add the exponents. Okay, so this is probably new for you. I also want you to write this down. The way that we're going to do this, you multiply the coefficients. Those are the numbers in front. Okay, so you multiply the coefficients, and then you add the exponents for all the same type of variable. So let me show you what I mean. Let's try some examples, and this will hopefully make a little bit sense. But this is really important. This is how you do it. So we're going to multiply the coefficients, but we're going to add exponents. In these examples, it says find each product. Remember that a product is what you get after you multiply, okay? We can also see that we're multiplying because we have terms separated by parentheses. And when parentheses are touching other things, that indicates multiplication. So even though on number 12, we have a monomial times a monomial, because there's not a plus or minus between them, altogether, this is still considered one term, okay? But don't worry too much about that. Okay, so we're multiplying these terms together. First thing, let's look at your coefficients, the 3 and the 4. So we're just going to multiply those just like if you did 3 times 4, and you'll get 12. Okay, now let's look at the variables. Our variables are both in, right? We're going to add their exponents, though. So we have n, now 2 plus 4 is 6. And the reason why we add, if you ever forget the rule, think about what this means. N squared, okay, means n times n. N to the fourth means n times n times n times n. Well, if I'm multiplying all of these together, right, n times n times n times n times n times n, there's 6 n's. N to the 6. Okay, let's try another one. On 13, look at your coefficients. Negative 3 times 5 is negative 15. Now let's look at our variables. This time we have two different type of variables. Let's focus first on the a's. Okay, I've got a to the second power, and I don't see an exponent, but I know there's a 1 there. Very important that you write that. So I'm going to add the 2 and the 1 that are the exponents of my a's, and I'm going to get a 3. Okay, now let's look at the b's. The b's have exponents of 3 and 4, so we're going to add those, and we'll get an exponent of 7. Okay, so you're adding the exponents of the variables that are the same. Let's try another one. Our coefficients are 2 and negative 3. Now I do have a 1 in front of this one, but multiplying by 1 doesn't change any value. So 2 times negative 3 times 1 is negative 6. And it looks like we have two variables here. We've got a and b. So I'm going to write them both down, and then I'm going to plug in their exponents. So let's look at the a's. First of all, our first a has an exponent of 1. Our second a also has an exponent of 1. Remember, if you don't see it, there's a 1. Please add that to your paper. And then my last a has an exponent of 2. So I've got 1, 1, and 2, if I add those up, that's an exponent of 4. For my b's, my exponents are also 1, 1, and 5. So 1, 1, and 5 add up to 7. So negative 6 times a to the 4th times b to the 7th. Let's try some more. All right, on 15, we have fractions. Don't be scared. Just remember how to multiply fractions. When you multiply fractions, you multiply the numerators together and then the denominators. The denominators are easy. 3 times 5 is 15. Okay. Let's do our numerators. First, we're going to start with our coefficients. 20 times 12 is a big O number. 240. Woo! And I'm using this as my fraction bar. Now let's look at our variables. We've got x and we've got y. Our x exponents, are 2 and 3. 2 plus 3 is 5. Make sure that you are adding and not accidentally multiplying. It's really easy because when you're multiplying your coefficients and then you go to add, it's really easy to want to keep multiplying. Now let's look at the exponents of our y's. We've got a 1 and a 5. 1 plus 5 is 6. Sorry, I cannot write this 6. Hold on. So, our variables, we've simplified those by multiplying them. The last thing we need to do is we need to make sure our fraction itself is simplified. So we're going to look at the coefficients in front. 240 over 15. If you type that into your calculator, that will simplify, I believe, to 16. So that will be in the numerator. So this whole fraction is going to simplify to 16 x to the 5th y to the 6th. And that's the simplified answer there. All right, let's keep going. All right, on number 16, notice the plus. So we're actually going to be combining what we did in our last video with what we're doing now. So we're going to multiply these, right? Because PEMDAS says to multiply, and then we'll add. Okay, so that's kind of our plan here. All right, so let's multiply the first two monomials together. So our coefficients are 3 and negative 2. 3 times negative 2 is negative 6. Okay, now let's look at our variables. The x's have exponent of 4 and 2. 4 plus 2 is 6. Now let's look at our y's. Our y's have exponent of 6, and this guy over here is an exponent of 1. 6 plus 1 is 7. Okay, so that's the first part. Plus, now we're going to multiply these two guys together. Let's look at our coefficient. I only have 1. I have an 8. Now I do have a 1 over here, but 8 times 1 is just 8. So we're going to have 8. Let's look at the exponents of our x's. I've got a 3 and a 3, so 3 plus 3 is 6. Now let's look at the exponents of our y's. I've got 2 and 5. 2 plus 5 is 7. So now let's go ahead and look. Can we add these two terms together? Remember, in order to add monomials, they have to have the same variables, which they do. They both have x and y. And they have to have the same exponents on those variables. So I have x to the 6th and y to the 7th. So these are actually like terms. And remember, when you add like terms, you just add the coefficients. So we're just going to add the coefficients. We're not going to do anything with the variables and exponents. So our variables and exponents are still going to be x to the 6th, y to the 7th, but we're going to add the negative 6 with the 8, which is going to give us a positive 2. Okay? Write a little note off to the side if you need help with that one, and I can help you. Number 17, in this one we have parentheses, and we do have something in front, so we are going to be multiplying. We're going to be distributing that negative 6t times these three terms. Okay? You may want to write this out at first. Write down the three things that you'll be multiplying, or you might just want to do it in your head. Okay, so let's kind of do this together. I'm gonna back up my arrow so we can focus. Okay, let's first do, and I'm gonna circle negative 6t times t squared. So t squared has a coefficient of 1. Remember, we're multiplying, so we're going to multiply our coefficients. Negative 6 times 1 is just negative 6. Now we're going to look at our variable, which is t, and we're going to add those exponents. The t on negative 6t has an exponent of 1, and then the t squared has an exponent of 2. 1 plus 2 is 3. So there's the first one. Now we're going to do negative 6t times 5t. So we're going to multiply those coefficients. Negative 6 times 5 is negative 30. And then we're going to add the exponents of our t's, which is 1 plus another 1, which is 2. All right, now we're going to multiply the negative 6t times our last term, which is negative 9. Negative 6 times negative 9 is positive 54. And then we still have that t. Now our 9 doesn't have a t, but we're multiplying, so we're putting it all together. So we're just keeping that little ot with the exponent of 1. You can write the 1 or not. Go back, make sure to look at all your terms, make sure that none of them are alike. If they are alike, you can combine them. We do have t's in all of our terms, but they all have different exponents, right? So we can't combine any of them. So this is simplified. This is our answer. Okay, we're not going to do 18 and 19 together. If you want to try to do it, pause it and try to do it, and then press unpause and I'll have the answers for you. Otherwise, we'll just skip ahead to number 20. Here are the answers to 18 and 19 if you were attempting these. If you weren't attempting them, maybe just look it over and see if these solutions make sense. Let's do our last example now. So the reason why I didn't want to leave off number 20 is because this is an application, and like I said, you'll probably see these type of questions asking for a perimeter and area of shaded figures on PSAT, SAT, and TSI. This is asking for both perimeter and area. Okay, let's focus on the perimeter first. Perimeter, remember, is the distance around a shape. So you're basically just going to add up the length of all the sides. It looks like we've got 1, 2, 3, 4, 5, 6, 7, 8 sides. So we're just going to add them together. So this side on the left is 5BC. Down here we've got BC. On this side we've got BC. Now this side right here is going to be the same as this 4BC up here. So I'm just going to rewrite it. Down here also, they should have the same length. So 4BC and then this 4BC. I'll come back to this side in a minute. This other short side up top is BC, and then this side up here is going to have the same length as this BC down here. So this will also be BC. Let's look at this question mark on the right. So that side is going to be a little bit shorter than this 5BC on the left, right? Well, how much shorter? If I take off the BC up here and the BC down here, let me get some different colors. BC and BC, if I subtract those from the 5BC, that should be the length of this guy, right? So this side is going to be, let me erase this real quick. This side is going to be 5BC minus the 2 BCs. Okay, the 1 BC on the top and the 1 BC on the bottom. Okay? All right, so I have circled my 8 side lengths. We are going to add them all together because that's what perimeter means. Okay? So if you look, every single term has BC in it, right? So we're just going to be adding together coefficients. So I've got, let's go ahead and figure out what all our coefficients are. We've got 5, we've got 1, we've got 1, we've got 4, we've got 5, we've got negative 2, we've got another 4, we've got another 1, and we've got another 1. So we're adding 5 plus 1 plus 1 plus 4 plus 5 plus a negative 2 or minus 2 plus a 4, plus a 1, and plus a 1. So if we add all that, we should get 20 BC. Okay, you see how that works? All right, now let's take a look at the area. So area is going to be the gray shaded part inside, right? Now this is called a composite figure. It's not a shape that we normally think of. Oh, a T shape. That's not a shape, right? But it's made up of some smaller rectangles. If I was to draw a line right here, right? I've got this rectangle over here, and then I've got this rectangle over here. And I can add those two areas together. So let's look at that long, skinny rectangle. Remember, the area of a rectangle is just length times width. So its length and width are, and this is for area, 5 BC times 1 BC. That's the area of that long, skinny rectangle. Plus, we're going to add the area of the other rectangle. Its length and width are 4 BC. And this guy is this 5 BC minus 2 BC, which is really just 3 BC, right? So it's 4 BC times 3 BC. Okay, we had an example kind of like this. We're going to multiply the two to find the areas, and then we'll add them together. So on the left, 5 BC times 1 BC, we're going to multiply our coefficients. 5 times 1 is 5. And then we're going to add the exponents of like variables. So our b's exponents, 1 plus 1 is 2. Our c's exponents, 1 plus 1 is also 2. Plus, on the right, we're multiplying. So 4 times 3 is 12. And then again, we're going to add the exponents of our like variables. So 1 plus 1 for the b is b squared. And 1 plus 1 for the c is c squared. So now we've got 5b squared c squared plus 12b squared c squared. B squared and c squared are in both of them, so these two terms are like. So we're just going to add the coefficients. 5 plus 12 is 17. B squared, c squared. Now this one was a little bit tougher, but as long as you get the basic idea, multiply the coefficients, add the exponents when you're multiplying. All right, bring me your questions, and I'll see you later.